Hi, welcome to our math. Today I'm doing a series of videos on parabolas, and we're going to discuss how to graph a parabola in vertex form. In this video, I am going to talk about how A affects the graph. So we're going to start off with graphing y equals x squared. If I take these values, -2, 1, 0, 1, 2, and square them, a number squared is always positive. I get -2, 4, 0, 1, -1, 1, 0, 0, 1, 1, 2, 4. If I graph this, I get -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and I get a slowly curving parabola. Now, if we look at this, the domain, because this goes forever left and right, the domain is all real, which I usually do in interval notation. You could do double bar R. You could just do the words, all real. I'm going to stick with interval notation. The range, however, what y values exist for this graph, well, the graph starts exactly at y equals 0 and goes straight up. So my range is 0 to infinity, or y is greater than or equal to 0. Okay. So let's look at our next graph. Our next graph is y equals 0.5 x squared. So -2 squared is 4 times 0.5 is going to be 2. -1 squared is 1 times 0.5 is 0.5. Anything times 0 is 0. 0.5, 2. So I have -2, 2. -1.5, 0, 0. 1.5, 2, 2, and we can see we have a very similar graph. It's just a little wider. The domain is still all real. The range is still from 0 to infinity. All right, let's look at a third graph. The third graph that we're going to look at is right here. So we have y equals -3x squared. Well, -2 squared is 4 times 3 is -12. -1 squared is 1 times -3 is -3. Anything times 0 is 0. This should be a -4. Sorry. Wait, no, that should be a -3. 1 squared is 1 times -3 is -3. 2 squared is 4 times -3 is -12. All right, so we have -2, -12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is not on the graph. We're not going to worry about it. -1, -3, 0, 0, 1, -3. We have a much skinnier parabola and one that's going down instead of up. The domain is still going to be all real, but in this case, the range is going to go from -infinity to 0. The -infinity always needs to be put on the left-hand side. That's very important when we're dealing with interval notation. Never put the -infinity on the big side. Okay. It says then, as we investigate this, it says, what is the value of A in each of the graphs? Well, in the first graph, A was 1, because we just did y equals x squared. In the second graph, A was 0.5. In the third graph, it was -3. All right, so how does A affect the graph? If A is positive, the graph goes up. If A is negative, the graph flips downward. If A was greater than 1, if you remember from the -3, when it was greater than 1, we had a stretch. So that our parabola got skinnier. I think of it as going faster. Instead of going 1, 1, it goes 3 times faster to 1, 3, or 1, -3. If it was between 0 and 1, we already dealt with the negative here, we have something called a shrink. So a shrink is going to make it look wider. And one way to think about a shrink is that this is going slower. It's going 1/2 or 1/3 the speed of your regular original graph. The last question we have is, what did we notice about all the domains? So let's kind of come back up here and look at all of the original domains from the very first one to the second one to the third one, because all we're doing is squaring the input. The thing we can realize about all of the domains is all of the domains are all real. There are no restrictions on a domain of a parabola outside of an application problem. All right, I hope you enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks!